The Instituto de Astronomía of UNAM and the Instituto Nacional de Astrofísica Óptica y Electrónica present Astronomy from Mexico, Past, Present, and Future. Why do we observe the sky? Since time immemorial, human beings have sought answers about the origin of the universe and the role of humanity in the cosmos. By studying the stars, we try to understand the origin of Earth and of life itself. Mexican astronomy has great tradition, and Mexicans have been at the forefront of astronomy for a long time. The National Astronomical Observatory was created in 1876, and 2 years later, its facilities were inaugurated in Chapultepec Castle. Later, its headquarters were relocated to Tacubaya. In 1929, the National Astronomical Observatory was incorporated into the Universidad Nacional Autónoma de México. Fleeing Mexico City's light pollution, in 1942, the National Astrophysical Observatory opens in Tonancintla, Puebla. With the Schmidt camera, its main telescope, important discoveries were made that gave birth to modern astronomy in Mexico. However, in 1971, looking for darker and better quality skies, astronomers chose the Sierra of San Pedro Martir in Baja California to install the National Astronomical Observatory, or OAN in Spanish. That same year, the Observatory of Tonancintla is transformed into the Instituto Nacional de Astrofísica Óptica y Electrónica, INAOE, its main project being the development of an observatory in Cananea, Sonora, today called the Observatorio Astronómico Guillermo Haro, which was the first large-size mirror polished in Mexico. In the late 80s, it was already clear that the observational infrastructure of Mexico was significantly below the capacity and ambition of its scientific community to generate cutting-edge knowledge. All the large telescopes throughout the world were by then the product of multinational investments. It has been widely shown that developed countries achieve exponential progress in many areas thanks to the development of basic science, in particular astronomy, that results not only in new knowledge, but also in a wide spillover in technological and economic terms. There are powerful examples of large scientific projects developed in our country. The Large Millimeter Telescope Alfonso Serrano, a binational project of INAOE and the University of Massachusetts Amherst, is the largest and most complex scientific project in Mexico to date in any field of knowledge. The LMT is a radio telescope that has a parabolic antenna of 50 meters in diameter and a collecting area of about 2,000 square meters, making it the largest of its kind in the world. It is located at the top of the Sierra Negra volcano, 4,600 meters above sea level. With the LMT, physical processes that govern the formation and evolution of planetary systems, stars, black holes, and galaxies through the 13.7 billion years of cosmic history are being explored. With this leading-edge facility, new millimetric wave astronomers and engineers have been developed in the country that have made great contributions to academic and educational institutions as well as to national industry. Since its first scientific light, obtained on June 1, 2011, the LMT has produced important astronomical results which have already been published in specialized international journals. Currently, observations are being made in connection with other radio telescopes around the globe to act in effect as a single telescope of about 6,000 kilometers in diameter. Also sponsored by the INAOE, astrophysicists and high-energy physicists of several national centers created a partnership to install in Mexico the Gamma and Cosmic Ray Observatory, or HAWC, High Altitude Water Cherenkov Observatory. This project, also a binational endeavor with the United States, and which involves numerous institutions in both countries, belongs to the new generation of observatories called Water Cherenkov facilities, which need to be installed at over 4,000 meters above sea level. The decision in 2007 to locate the observatory in our country was not only based on the academic strength of our researchers, but also because there was an ideal site for it, the Pico de Arizaba National Park. An appropriate site due to its height, its accessibility, and its proximity to the LMT equipped with a modern communications network. HAWC is integrated by 300 Cherenkov detectors, each consisting of a large container of ultra-pure water, 5 meters high and 7.3 meters in diameter, equipped with high-sensitivity instruments. The observatory was inaugurated in March of 2015. HAWC detectors record the passage of high-energy particles. This telescope is led by the INAOE and the UNAM in Mexico and the University of Maryland and Los Alamos National Laboratory in the United States. HAWC is the world's largest telescope of its kind and is currently capturing about 20,000 cosmic rays per second. In the coming months and years, it will unveil in great detail the nature of the most energetic events in the cosmos. Mexican institutions and scientists have demonstrated their enormous capability to plan and develop major challenges in scientific research. Thus, today, the objective is to take advantage of the privileged site Mexico has within its territory that retains its enormous potential ground-based astronomy. The National Astronomical Observatory in the Sierra of San Pedro Martir is one of the top 4 sites in the world for optical infrared observation due to its natural characteristics: high altitude, number of clear nights per year, sky darkness, low water vapor and cleanliness, and stability of the atmosphere. This site is well known and is visited by professional astronomers around the world who also work in the other 3 sites that compare with our majestic sky: Hawaii, the Canary Islands, and the Atacama Desert in Chile. The investment in scientific infrastructure at these top 3 international sites is registered at $6 billion on average, while at SPM it is only $30 million. There is thus much that remains to be done. This effort, led by the Institute of Astronomy at the UNAM, is currently carried out through specific projects that ensure the preservation of the site and serve as leverage for the scientific and technological development of our country. The first ingredient needed is a dark sky, and the state of Baja California is the only one in the country with state and municipal legislation for the prevention of light pollution. This ensures that this legacy, part of our cultural and natural heritage, is protected for future generations. To improve the infrastructure, an agreement was signed with the Federal Electricity Commission for the installation of an 80-kilometer power line to the site from the Transpeninsular Highway of Baja California. Taking advantage of this installation, fiber optics is also being installed to ensure reliable communications with the required bandwidth. The telescopes installed today at San Pedro Martir are all from the 1970s. The most recent, with a 2.1-meter aperture, was inaugurated in 1979. In order to tap the huge potential of this site for use as a lever for scientific and technological development projects, it requires short, mid-term, and large-scale projects with national and international partners. Today, there are several projects of scientific, technological, and infrastructure nature for the site with the United States, Taiwan, France, Spain, and various national institutions. The largest project underway today is the Telescopio San Pedro Martir, or TSPM, which will carry out the design, construction, and operation of a 6.5-meter optical infrared wide-field telescope. This is an initiative between the Mexican astronomical community, led by UNAM and INAOE, and the University of Arizona and the Smithsonian Astrophysical Observatory at Harvard University from the United States. In 2012, in collaboration with these American institutions, the idea of creating a binational astrophysics laboratory between the U.S. and Mexico was put forward, taking advantage of the existing MMT telescope on Mount Hopkins, Arizona, to operate it in a joint and complementary way with the new TSPM in Mexico. In our country, the collaboration also includes other astronomical research institutions, such as the National Polytechnic Institute and the Universities of Guadalajara, Guanajuato, and Sonora. Together, the INAOE and the University of Arizona provide the primary mirror of 6.5 meters, which has already been manufactured. Mexico will take over the construction of the telescope and its building, which is currently in the design phase, with the support of the National Council of Science and Technology. U.S. partners will provide additional scientific instruments and optics. Both communities will be able to use the TSPM as well as the MMT, multiplying the options for scientific collaboration and the development of human resources and technology. Developing the TSPM in San Pedro Martir implies an unprecedented impact in applied technology in Mexico, where most of the investment will be directly deposited. With the progress made and the specific contributions already committed and under development, the viability of the project is assured. However, it is still necessary to have strong support from the public and private sectors to consolidate this wonderful project that will benefit in many ways all the agencies and institutions joining this powerful alliance. The national astronomical community, united today to accomplish this great challenge, will be able to take advantage of the unique features of San Pedro Martir by installing a world-class instrument and by strengthening the ties with its international counterparts to consolidate Mexico's position at the forefront of the world's astronomy. With the sites of San Pedro Martir and Sierra Negra, our country has the capacity to be an important international player over the next decades in the realm of multi-frequency astronomy, making discoveries through observations at high energies, millimetric wavelengths, and visible and infrared radiation. It is a powerful combination that few countries can boast of, and that Mexico is fortunate to be able to develop in a responsible and consolidated way within its territory and for a broad national benefit.